Hello, hi students. Welcome to my channel. Today we are going to discuss previous year NEET questions from oscillation chapter. Our first question is: a spring is stretched by 5 centimeters by a force of 10 Newton. The time period of oscillation when a mass of 2 kg is suspended by it is. Okay, now let us see what he gave. He said that this is a spring, and to this spring a force of 10 Newton is applied in downward direction. Because of this 10 Newton force, this spring got extended by 5 centimeters. Okay, it got extended by 5 centimeters. Now, to the same spring, he hung a mass m is equal to 2 kg. Okay, he hanged a mass of 2 kg and left this mass. When this mass is left, this system, spring block system, made oscillation with some time period t. Now he is asking us to calculate the time period. Okay, let me take this as case 1 and this as case 2. Now we have to calculate time period. We know the formula for time period as t is equal to 2 pi root m by k, where small m is the mass hanged to the spring and k is the spring constant of the spring. If you see, we know the value of small m, but we don't know the value of k, which is spring constant. To calculate k, I'll use case 1. Okay, what did he give? He said that he applied a force of F is equal to 10 Newton, because of which the spring extended by an amount of 5 centimeters. That is equal to 5 into 10 power minus 2 meters. Okay, now we know that in the case of spring, the formula for force is F is equal to minus kx. If you neglect this minus, okay, or if you neglect this minus, then what will you get? F is equal to kx. That implies spring constant k is equal to F by x. Okay, so k is 10 by x is 5 into 10 power minus 2. Okay, if we solve, what will you get? 0.2 into 10 cube Newton per meter. Okay, so you got the value of k. Now you have to calculate the value of time period. Okay, time period t is equal to 2 pi into root over m 2 by k 0.2 into 10 cube, that equal to 2 into 3.14 into root over 2 by 2 into 10 square. Okay, this two will get cancelled, and what will you get if we solve? 6.28 by 10, that is equal to 0.628 seconds. Okay, now let us move to our next sum. A body is executing simple harmonic motion with a frequency n. The frequency of potential g is. Okay, now let us see what he gave. He said that this is a body which is undergoing simple harmonic motion with a frequency of n. Now he is asking us to calculate the frequency of variation in potential g. Okay, we know that the value of potential g will be 0 at mean position and it will be maximum at extreme position. Okay, it will be maximum at extreme position. As the particle goes from mean to extreme position, the value of potential g will increase, reaches to its maximum value and again decreases, reaches to 0 and again goes to maximum value in the opposite direction. Okay, and again it becomes 0. Okay, we can clearly notice that for one oscillation, the value of potential g is reaching to its maximum value twice. Okay, that is, if the time period of oscillation is t, then the time period of variation in potential g will be equal to t by 2. That is, if the frequency of oscillation is n, then the frequency of variation in potential g will be 2n. Okay, so the answer is 2n. Now let us try to solve this sum using displacement time graph and potential g time graph. Okay, this is the graph that shows the variation of displacement with respect to time, and this is the graph that shows the variation of potential g with respect to time. Okay, now let me consider a time t dash which is far less than 1 second. Okay, within a time period of t dash, the particle is undergoing one oscillation. Okay, the particle is undergoing one oscillation. Now in the same time period t dash, okay, in the same time period t dash, the potential g is reaching maximum twice. Okay, and it is clear that this potential g is making two oscillations, or this potential g is varying twice. Okay, so what is the conclusion? For a time t dash, if a particle undergoes one oscillation, the variation of potential g is undergoing two oscillations. That is, for a time period of 1 second, if the particle undergoes n oscillations, then for the same 1 second, the variation of potential g will undergo 2n oscillations. That means if the frequency is n in this case, then in this case the frequency will be 2n. If you feel that this video is useful, kindly share to your friends. If you have any doubts or suggestions, you can comment me in the comment section. Do like and subscribe because your single like and comment will encourage me for making better videos. Thank you.